So this is the 27th video on rigid body kinematics. This is in continuation of the 26th video. Okay. So in this also I'll take up numerical problems on pure rolling motion from acceleration point of view. Okay. So I'll take up some more numericals. So I'll write down the numerical, alright. So you go through them. So before going ahead, one thing I would like to emphasize again that if you study all the matter from this channel, then study from YouTube itself. You don't have to go anywhere else. Okay. If you thoroughly understand all this point, theory and numerical, everything which is given in this channel, in the videos of this channel, then if you understand them, then I think it's more than sufficient. You don't have to go to any other place, any other coaching institute for that studying these things. Okay, because this is exhaustive and absolute. Okay. So if you understand this, it's fine. And then you can take up numerical from any other source. You try it, and I think you'll be able to solve most of them. In case you are not able to solve one or two numerical, you just write to me on the comment box. I'll just see it and then I'll clear your doubts. Okay, fine. So now I continue. All right. So I'll take up numericals on rigid body kinematics. Okay. So question is this. In both the details shown below, in both the diagrams shown below, all the details are given. In both the diagrams, shown below, are given. Okay. Find the value A by R beta in both cases by several methods. And A and beta will be specified in the diagram of the problem which I'll show. Okay, fine. So first problem is this, part A. I'll draw the diagram here. This is the fixed horizontal ground surface. This is a translating plank. Plank which moves at an acceleration of say 5a with respect to g. G meaning ground frame. This is a horizontal ground surface, fixed. This is a circular drum. Okay. This is a circular drum with center at C and radius R. Center moves ahead at an acceleration a with respect to ground. A with respect to ground. Okay. And sense of rotation is anti-clockwise. Omega and beta are both anti-clockwise sense with respect to ground. And here pure rolling takes place. Here what takes place? I'll draw the arrow like this, pure rolling. Alright, fine. So here pure rolling is taking place. Center is moving at acceleration a with respect to ground in rightward direction. Plank is moving at acceleration of 5a with respect to ground in rightward direction. Omega and beta are with acceleration of angular velocity and angular acceleration of drum with respect to ground at the given instant. Both are anti-clockwise sense. This drum undergoes pure rolling over the plank. Now we have to determine the value of the quantity A by R beta. Okay, by several different methods. Okay. So now see, this problem can be solved by four different methods. Four methods. Four methods, yes. It can be solved by four different methods. Okay. So this can be solved by four different methods. I'll solve this by four different methods. Okay. First M1. Method 1 is we apply SRC procedure for SRC method for acceleration in a ground frame. By SRC method, procedure. By SRC procedure for acceleration in G frame. G frame meaning ground frame. Method 2, by SRC procedure for acceleration in plank frame. This is the plank. By SRC procedure for acceleration in plank frame. Method 3, on the formula beta equal to relative normal acceleration by separation. Relative normal acceleration upon separation. In this also two subcases, in G frame, in plank frame. In G frame and in plank frame. So these are the four different methods by which the problem can be solved. In this method 3 and 4 both are in this. Okay. Method 3 and method 4 both are combined in this. Okay. I love this one. This portion I love also. See, you must know all the four methods. Okay. And then in the, if whatever exam question comes in the exam, there you decide which method will give me the answer in the best possible way, in least time. So you apply that method there. But you must know all the methods. You must know the theory from all aspects. Alright. I'll solve this by method 1. Okay. Okay. So I'll draw the diagram. So method 1, M1. So this is the center C of the drum which moves at an acceleration A with respect to ground. Omega and beta are both anti-clockwise sense. Plank moves at an acceleration 5A with respect to ground. At what acceleration? 5A. 5A. Okay, fine. Here pure rolling takes place. Let us take this point to be D. Material point. D is the material point of drum in contact with the plank. And P is the material point of the plank which is in contact with D. Here pure rolling takes place. Pure rolling takes place here. Now we know from the previous videos on pure rolling, 26th video on rigid body kinematics, pure rolling was discussed from acceleration point of view. So here pure rolling is taking place of drum over the plank. So accelerations of D and P along common tangent plane at the point of contact should be same acceleration in magnitude and direction both. So what we do, we find the acceleration of D and P along common tangent plane and equate them. So this is the unit vector along tangent, and this is the unit vector along normal E and hat. Okay. So we apply SRC for acceleration. SRC for acceleration between C and D. So SP arrow C, OP arrow D. Alright. SP arrow C and OP arrow D. Now we draw the line joining SP and OP, that is line CD is vertical. We give the acceleration of selected point C to other point D, which is simply A. Now omega is anti-clockwise sense, so we say the sentence D moves in anti-clockwise circle with C as center and radius R. For that I will give acceleration R beta to D rightward and omega square R towards center. The acceleration of D will be the vector sum of these two. So acceleration of D will be in along ET, it will be A plus R beta. A plus R beta ET hat plus omega square R En hat. This is the acceleration of D. Alright, fine. Now what I do, I find the acceleration of Planck with respect to point P of Planck with respect to ground. Now Planck translates at acceleration 5a and P is the material point of Planck. So acceleration of Planck with respect to ground is simply 5a into et. Now pure rolling takes place here. So component of accelerations of d and p along et, along tangent plane, that is along et, should be same. So a plus r beta should be equal to 5a. A plus r beta should be equal to 5a. So r beta is equal to 4a. So a by r beta is equal to 1 by 4, which is therefore the required answer. Alright, so this I solved by method 1. See, one fundamental point should be noted. Since we have applied SRC procedure in ground frame, so acceleration, angular velocity all have to be taken with respect to ground frame. And all a, 5a, beta r, or beta omega, they are all given with respect to ground. So there is no problem here, okay? Now we take up this problem by method 2. We take up this problem by which method? Method 2. We apply SRC by using SRC for acceleration in Planck frame. SRC procedure for acceleration in Planck frame. From SRC procedure for acceleration in Planck frame. Okay. Again, our aim will be what? To equate the accelerations of d and p along tangent plane, along the common tangent plane, that is along et. So that now what we have to do now, since we are applying SRC procedure in Planck frame, so we have to take all the accelerations, angular velocities with respect to Planck frame. This point should be kept in mind. Okay. So first of all, again, we'll equate the accelerations of d along common tangent and acceleration of p along common tangent. Okay. These both are with respect to Planck. Both have to be taken with respect to Planck. Alright. Both have taken with respect to what? Tell me. Planck. Now both have to be taken with respect to Planck. Omega, beta, everything we have to determine with respect to Planck. Alright. This I'll rub it, okay. Now first take this ADET and APET. Now what is APET? Acceleration of material point P of Planck in common tangent plane with respect to Planck itself. Now P is the material point of Planck. So and Planck is the rigid body. So acceleration of P with respect to Planck itself is 0. So this quantity becomes 0. So this quantity should also become 0. Now we find the expression for this and equate it to 0. We find the expression for this quantity and equate it to what? 0. Okay, fine. Now to find this expression for this, we apply SRC procedure for acceleration between C and D in the frame of Planck. Between C and D in Planck frame. Okay, fine. So for that, first we must know the acceleration of C with respect to Planck frame. And we must also know the acceleration of angular velocity and angular acceleration of drum with respect to Planck frame. Both we must know. Alright. So first we have to determine the acceleration of center C of drum with respect to Planck frame. The Planck translates with respect to ground. So from theory of translating frames, ACG is equal to ACPL. PL meaning Planck. PL meaning Planck. Plus acceleration of Planck with respect to ground. Okay. So acceleration of C with respect to Planck PL becomes ACG minus APLG. Alright. That is just ACG. ACG is nothing but vector A. And this becomes reverse Hanat procedure. It becomes minus 5A vector. Minus A Planck G. Okay. Now this quantity is A rightward given. And minus A PLG is 5A leftward. Reverse Hanat technique. So vectors of these two for parallelogram, now vector addition will be 4A leftward Okay, fine. So acceleration of center C with respect to Planck will be how much? 4a leftward. How much will it be? 4a leftward. Alright. So acceleration of center C with respect to Planck becomes 4a left. Now we also have to know the angular velocity and angular acceleration of Planck with respect to ground, with respect no, of drum with respect to Planck. So for that what we do, we apply the theory for angular velocity omega dg, angular velocity of drum with respect to ground. This d doesn't mean point D, it means drum. Is same as angular velocity of drum with respect to Planck, P for Planck, PL, plus angular velocity of Planck with respect to ground. Now Planck with respect to ground, Planck translates. It has no rotatory motion. So its angular velocity becomes 0. So angular velocity of drum with respect to Planck is just the angular velocity of drum with respect to ground. Okay. And angular velocity of drum with respect to ground is omega anti-clockwise. So this quantity also becomes omega anti-clockwise. Okay. Now we also have to determine the angular acceleration of drum with respect to Planck. That also we have to determine. Alright. So this are a bit, okay. Now we know angular acceleration of drum with respect to ground beta dg is equal to beta dp plus beta pg. Here d means drum, p means Planck, g means ground, minus omega dp cross omega pg. Okay, this was stated in the second video on rigid body kinematics, second or third video. If you go there, you will get it. Okay. Now beta dg is what? Angular acceleration of drum with respect to ground. That is simply beta in anti-clockwise sense. Beta dp is angular velocity acceleration of drum with respect to Planck. So which we have to find. Plus angular acceleration of Planck with respect to ground. This is 0 because this quantity is 0 because Planck has no rotatory motion. It is translating. It's going a straight line motion. So no rotation. So angular acceleration becomes 0. Minus omega dp cross omega pg. Okay. This I write it as here P means Planck, doesn't mean point P. This means Planck. So omega dp cross omega pg. Now omega dp is what? This just this quantity is nothing but omega in anti-clockwise sense, and omega pg is also omega in anti-clockwise sense. So vector omega cross omega, that just becomes 0 on the rule of cross product. So angular acceleration of drum with respect to Planck, that is also beta in anti-clockwise sense. So this fundamental point should be kept in mind. Okay. So now we have obtained all the things. Now what we do, we apply SRC procedure for acceleration between the points C and D in the frame of Planck. We apply the SRC procedure for acceleration between the points C and D in the frame of Planck. Now this is a bit, okay. So now what we do, SP arrow what C, OP arrow what D. I draw the line joining SP and OP, that is line joining C and D. Now I give the acceleration of C to D. Acceleration of C with respect to Planck, which was found just now. This was 4a left. So I give 4a to D in leftward direction. Alright, fine. Now I say the sentence. Omega is anti-clockwise. So D moves in anti-clockwise circle with C as the center and radius R. So I give two accelerations to D. Omega square R towards the selected point C and R beta along tangent, right? Rightward direction. So acceleration of D with respect to Planck becomes a dp. PL meaning Planck is the vectors of these two. R beta minus 4a et hat omega square R en hat. Okay. Now this is the acceleration of drum with respect to Planck. So acceleration of drum with respect to Planck becomes R beta minus 4a et hat plus omega square R en hat. Now since pure volume takes place here, acceleration of D and P along common tangent plane should be equal. That is the coefficient of accelerations of Planck and drum with respect to Planck along ET should be equal. So acceleration of D along top tangent plane is this much. R beta minus 4a. And acceleration of point P along ET is what? 0. So this is equal to 0. So 4a is equal to R beta. So A by R beta becomes 1 by 4. Same answer which we obtained previously. Okay. So a by r beta becomes 1 by 4. So this I demonstrated by method 2. So in this I best use that concept. But one fundamental point should be noted: whenever we apply SRC procedure for velocity or acceleration, it has to be applied in a reference frame. And all the velocities, angular velocities, angular accelerations, velocities, accelerations, they all have to be taken with respect to that given frame in which the SRC is being applied. So this fundamental point should be noted. Okay, fine. This one I rub it, okay. Now let's discuss this by method 3. Method 3, what I do, I apply the concept beta is equal to relative normal acceleration by separation. Okay. Now see, this in ground frame. This I mentioned there just now when I rubbed it before rubbing. Okay. So if you be right, I'll write it here. Beta is equal to relative normal acceleration in separation in G frame. G frame meaning what? Ground frame. So what I do first, I draw the line joining C and D. I draw the line joining C and D. C and D radius is R. Acceleration of, now in ground frame we are doing, so all the accelerations and all the angular velocities and all the angular accelerations have to be taken with respect to ground. So acceleration of C with respect to ground is A. Okay. Now I determine method 1, I found that acceleration of D in ground frame, acceleration of D in ground frame, just I'll repeat this. Now we have to know the acceleration of D in ground frame. Okay. So for since I discussed in pure rolling point of view, from pure rolling point of view I discussed. So Planck has an acceleration of 5a rightward, so this point also has the same acceleration of 5a rightward in this direction. A plus r beta, 5a. You discussed method 1, I discussed. So acceleration of D along common tangent plane is 5a. And this side there is omega square r. This I just applied method 1, I determined. Here it was a plus r beta, that is just equal to 5a, pure rolling criteria. So I am using that result, method 1. As I solved this problem method 1, I showed a plus r beta, SRC procedure allied, and that was equal to 5a, so 5a and then omega square r. Now beta is equal to, beta is anti-clockwise sense, so beta is equal to relative normal acceleration by separation. Now both these normal accelerations are in same direction. So from theory of relative acceleration between two moving points, relative normal acceleration becomes 5a minus a by separation is r, that is just 4a by r. So a by r beta becomes 1 by 4. Same answer has been obtained again, you can see it. Okay, fine, alright. Now this one I rub it, okay. So method 3 also same answer we have obtained, alright. Method 4. We apply the formula beta is equal to relative normal acceleration by separation in Planck frame. Beta is equal to relative normal acceleration by separation Planck frame. So again what I do, I draw the line joining C and D. Now when we apply this formula in Planck frame, an acceleration of C and D have to be taken with respect to Planck frame. Now I discussed in method 2 this problem. Acceleration of C in Planck frame is 4a left, and acceleration of D along tangent plane is 0 with respect to Planck because of pure rolling. And this side is omega square r, and this is beta. So beta becomes relative normal acceleration by separation. Acceleration of C in normal direction is 4a and of D is 0. So relative normal acceleration becomes 4a plus 0 by r. That becomes 4a by r. So A by r beta becomes 1 by 4, which is therefore the required answer. Okay. So these are demonstrated by 4 different methods. But you can say that best method is this method 4. Method 3. Applying the formula relative normal acceleration by separation in ground frame. That is the best method of solving this problem. In case such an example comes up in JEE Mains or Advanced, in my view, third method is the best way. That gives you the answer in minimum possible time. Okay. Now I have this one. Okay. This are a bit. Okay. I take up another example, sub case B. Again, I draw the diagram. This is a translating plank. This is a circular drum with center at C and radius R. This moves rightward at a constant speed 6a with respect to ground, and center moves at an acceleration of a with respect to ground. Here, pure rolling takes place. And this rotates in anti-clockwise omega, and beta is also anti-clockwise. Both omega and beta are angular velocity and angular acceleration of drum with respect to ground. Both omega and beta are angular velocity and angular acceleration of drum with respect to ground. And A is the acceleration of center C with respect to ground, leftward. And 6a is the acceleration of plank with respect to ground, rightward. Now again we have to find the value of the ratio A by R beta. So again this can be solved by 4 different methods, as I did in the previous question on this video. But I will not solve all those 4 methods, I just solve 2 different methods. In method 1, what I will do, we apply SRC procedure for acceleration in ground frame. Okay. By SRC procedure for acceleration in G frame. And method 2, I'll write first I solve it. Okay. So first of all, I take this D to be the material point of drum in contact with material point P of the plank. Okay, fine. Now we apply SRC for acceleration between C and D. SRC for acceleration between C and D in ground frame. So SP arrow C, OP arrow D. I draw the line joining C and D. I give the acceleration of center C to D. Acceleration of C is A left, so I give A left. Okay, fine. Now I write down the sentence. Omega and beta are both anti-clockwise. So D moves in anti-clockwise circle with center at C and radius R. So 2 accelerations have to be given to D. Omega square R towards center and R beta along rightward direction. Alright, fine. Now this I take unit vector ET hat as I did in part A of the question. And this I take as EN hat. Okay. Unit vector along upward downward. ET hat is unit vector along tangent plane at the contact point. So acceleration of D is the vector sum of these 3. So acceleration of D with respect to ground is just omega square R En plus R beta minus A into ET. R beta minus A into what? ET hat. This is the acceleration of D. Component of acceleration of D in tangent plane is R beta minus A. Okay. Now I find the acceleration of P with respect to ground. Now P is the material point of this translating plank. In translating body we know that all points have same acceleration. The acceleration of P with respect to ground is simply 6a. That is simply along ET. So ET hat. Now here pure rolling takes place. So component of accelerations of D and P along common tangent plane should be equal. So coefficient of this and this ET in both equations should be same. So R beta minus A should be 6A. R beta should be 7A. So A by R beta should be 1 by 7 is therefore the required answer. Now again one point I have emphasized, since I have applied ground frame SRC for acceleration in ground frame, so all the omega and beta have to be taken with respect to ground frame and they are given in the problem, so there is no no need of calculating it again because it's already given in the question. Okay, so this is one answer. I will solve this by method 2. So method 2 will be what? By applying the formula beta is equal to relative normal acceleration by separation. Relative normal acceleration by separation in G frame. You can apply in Planck frame also. Okay, but I am just using the G frame. That is the best way, as I discussed in previous question, method 3. Then here this is method 2. So I draw the line joining C and D. Acceleration of C is given to be A left. Now see, here pure rolling is taking place. So acceleration of point D of drum in tangent plane is simply equal to that of this Planck. This is D. So this is 6A. And this here it is omega square R. So normal acceleration of C is A left. And normal acceleration of D is 6A right. Both are opposite directions. So from theory of relative acceleration between two moving points, angular acceleration beta is relative normal acceleration, which is 6A plus A. Plus A by separation is simply R. That just becomes 7A by R. So A by R beta becomes 1 by 7. Which is therefore the required answer. Okay, fine. So A by R beta, value of A by R beta becomes how much? Value of A by R beta becomes 1 by 7. Okay. Value of A by R beta becomes 1 by 7. It is therefore the required answer, which we obtained by other method also. Okay. So this was the 27th video on rigid body kinematics. Okay. So in next video also I will take up some more problem on this pure rolling from acceleration point of view. Fine. And then I will pass over to last chapter on rigid body kinematics, that is the concept of instantaneous center of rotation, that is IC concept, very powerful concept. Okay. This is a bit here. Fine.